Java is known for object-oriented programming. But then, after Java 8, there has been introduction to functional programming into the Java. You might have heard about the Lambda expressions and the streams API. So these are new implementations into the Java language, and this is what we will cover in this session. So let me use the full screen mode and then we will begin. So what I am doing here is I have a environment setup which is it's basically designed for Python, but I'm using Java here. So this is called Jupyter Notebooks. We'll use it and this is very good environment to try out any new APIs and play around with any of the language features. So the details and all I will share later, but yes, let's begin about Java functional programming, and then we'll not get into too much of details about the environment setup and all. You can use any environment as per your convenient, any ID, but for easy presentation I'm using this environment. So all the functional APIs are available in this package, and this package is called java.util.stream. Now functional programming focuses on using functions, as the name suggests. Functions are the primary building block of software development in functional programming. Now, what are the benefits of functional programming? Functional programming leads to more concise and maintainable code. Right? And this package contains various classes, interfaces, enumerations to support functional style operations. So before we begin, let's study about streams. What are streams? Because this is also a very important concept. A stream is nothing but a sequence of objects. So there could be a lot of objects within a stream. Stream can be a stream of integers, a stream of strings, or a stream of any objects. And streams support aggregation operation. So they support advantage of streams, they support aggregate operations. This is slightly different from collections, but yes, any collection could also be converted to a stream. Now if you use functional programming, you will see we can use a coding style which is also called declarative style. When we write usual programs, the programs we write are called imperative programs because we have to specify the logic, how to achieve any functionality. So just this is a notes, so I'll just put this here. Yes, so in imperative programming, you don't focus on how to achieve the things, you just specify what you want to do. So let's see an example. Let's create an employee class. So I have a Java code here now I'm showing, which is a employee class. It has two properties, which is name and gender, and name is of type string and gender is a type enumeration. Let me also declare a enumeration quickly. Yes, just a minute, let me see if Yes. Okay. I was just wondering, in case someone is joining, then I will have to allow him to this session. So yeah, this is how we enable, we define enumeration in Java. I use the keyword enum and then gender, and then I specify what all constants I would need, and automatically there will be an ordinal number which will be specified to them. Right. So we have defined the getter methods, and we have defined a constructor which takes two argument, and we have defined a toString method if just we want to print this properly. So these are my classes which are defined. So if I have to create a list of employees, I will do something like this. I'll declare a list. It is of type employee, and I say employee list, and there is some new method which is available. We can create, for example, here new employee, and I can specify that this is the gender. So this will create a new employee, and at the same time it will also add these employees to a list, and which is we call employee list. So here we can use the other gender type, and I execute this. All right. So here, yeah, I should have. I don't need here the semicolons because this is within the method, and yes. So this is absolute. This is the correct syntax, and I execute this. Right. And now the employee list is created. Now let me see what's there in the employee list. If I have to print this employee list, I'll do it something like this. I'll iterate over all the employees, E in employee list, and then I print each of them, and I'll call the toString method. Alright, so now these two employees are printed. This format is coming because we have defined the toString method like this. So this is normal programming. So here this is what we used to do. But now we get a lot of new features with streams. So instead of this is declarative style, if we this is imperative style, and if we want to use something like declarative style, we'll see in the next few examples. Okay. So we'll keep this employee for the time being, and then we'll define some operations, functional interfaces on employee class, and then we'll see how to use them. So let's look into another term which is called functional interface. Functional interface is an abstract interface, is an interface which has only one method. So that's what is functional interface. And there is a Java class which is java.util.function, where various functional interfaces are defined. So this is just for your information. Right. So now let's say we have this employee list, any collection, as I said earlier, could be converted to a stream. So when I call this statement, I can convert this collection, which is a list of employees, to a stream. Right? So now this is converted to a stream, and then let's say I want to extract list of names of the employees. I'm just interested in printing list of employees. So what I can do is I use this stream, okay, and then I can say, okay, let's first show you how I achieve the same result, which is a for loop here. So here I'm not using any loop, I am using a method called for each, and I can do something like this. So it prints out, you see, the same result, but this is more of a declarative style of programming. We don't need loop for this, and we can iterate over the employee list and print and do some operation on this. Now this is something strange, little different syntax. I'll come to that. But before that, I can also do some filter, and I can say for all employees, I want to take out, right, let's say e.name. I want to filter employees, and employee, let's say I want to pick only employees which are male. So this I can do by saying that like this equals, so I have to use this value which is female, right? So here I'm filtering all the employees and then calling for each on this. So let's run this. Yeah, so here the gender, so it's saying private. Okay, so yeah, this we declared private, so we should use get gender instead. So let's use here a method, and then we will do the operation, right? So see, I am filtering out all the employees which is female. So this is the power of functional programming and how to use streams, because I can put some complicated logic as well here within this. And this syntax which I'm using inside, this is called Lambda expressions, right? So it means that for all of the items in this stream, E is the employee. I don't need to declare employee E here, and it can be inferred because this operation is running on employee list. Employee list is a list of employee, so this can be inferred very easily by the compiler. So we can just put some variable and then perform some filtering operation. So what it says is, I want to filter all the employees where the gender is equal to female. So this is how I'll use this, right? Now same thing I can use for each as well. I could have used E, and then I could have said system.out.println, and I could have done like this, right? So here for each employee, print the value, right? If I run this, now you see I get the same result. But I used here instead this syntax because it was more compact. So this is called functional references. So this is, I'm kind of method reference. I'm using the reference to the method or a function. So this is syntax has object, then 2 colons followed by println, which is the name of the method. So this is about how to convert a stream and how to perform some operations on streams. Is it clear, Kishore and Shrikant?
Yes, sir.
Okay, great.
Yes, sir, it is clear.
Perfect. And you are seeing the screen properly? No issues?
Yes, no issues.
Okay, great. Because sometimes the resolution issue could come, so that's why I just wanted to double check. Okay, perfect. Now let's move on to more advanced topic in functional programming. So let's define, as I said, yeah, you are saying something, Kishore?
No, sir. Please carry on.
Okay, perfect. So yes, let's start using functional composition. So there is a concept called functional composition. I'll introduce that. So yeah, this you would have understood. I would have done like I have to iterate over all the employees and then filter it out. If else statement would be required. With functional programming, this is not required. Yeah. So now let's cover the concept of functional composition. And in functional composition, what we have is let's define a function. So I'm creating a function as an object, and function object is generic data type, and let's call this multiply by 2. This is the function. And here 2 data types I have declared. Both are integers. First one is the value which is being passed to the function. Second is the return type. So now I can use lambda expression and I can define this function as multiply by 2 is equal to x, so that x multiply by 2. So this is a lambda expression which I have used. I can define something similar again. Let's say I define another function which is, instead of multiply by 2, I can say add 3. Right, so now I have to change here. This is similar to mathematical formulas or mathematical functions where you just define what would be your input and then what processing you need to do. So this is what you will be returning. And for every input x, you return x into 2 in case of our function multiply by 2. And in second case, for every input x, you return x plus 3. So I have 2 functions here defined. So this is a function class, which is a function interface which is defined within this particular package. Now let's use this. So how I can use this is, I can just simply say multiply by 2, and then I can call a method in the interface, which is function interface, which is called apply. Right? And apply, I have to pass some value. So what it will do, multiply by 2, and we passed 4, so it should return 8. Right, so I'll run this. So okay, sorry, I had some typo here. multiply by 2. So I'll run it again, and I'll run again, and I see I get 8, right? So instead of creating a function and then doing multiply by 2, we do this using functional interface. But what's the benefit of this? With this, you can write more readable code. So I will say how we can do composition of functions. So what I can do is multiply by 2. I can write like this, and I can say and then add 3, right? So this is, I'm writing like English, and I can say now I pass 4. So what will happen is, this is composition, so it will happen in reverse order. So it will add 3 to 4, so it will become 7, and then it will multiply 7 by 2, right? So no, sorry, this is and then. I have used and then, so this will happen multiply by 2 first, and then add 3. So 8, and then it will be multiplied by, so 4 multiplied by 2. So the way it will execute is, this is multiply by 2 I called first, and then I said add 3. So this what would be the equation. So if I run it, you see answer is 11, right? I could have used another function which is called compose, right? It's exactly similar than it is similar to and then function, but only thing is it does the things in reverse order. So in this case, it will first add 3, because I'm using functional composition and calling a compose method, and then it will multiply by 2. So in this case, it should return answer 14. Right, see, you got 14 here. So these are the two methods for functional composition, and you can compose, you can combine multiple functions and create new logic, new functions. So this is the concept of functional composition, and it has two methods. So hope this is clear, right? Now let's say we want to perform some operation. Let's say we call, we have some integer. Now let's do this. I already told this. I can capture this inside multiply by 2, or you can define another function. Let's say, let's define one more. I'll give one more example. So we have here a function, let's call it increment, and it could be like x equal to x plus 1, right? Now if I have to use it, I can use it like this. I have a num, and I can put some value here. I can say this is my function is called increment, and then I can say apply, and I say 3. So the value it should return is incrementing 3 with 1. Right, so now I have to print here. So to print, I can call this function render. I could have called system.out.println as well. So you see, when I apply 3 on 3 the increment function, I got 4. So this is one example. Yeah. There is another so another thing which I can do is I can create a class. I can call, say, calculator, right? And in this calculator, what I can do, I can create, okay, now don't need to create static methods. Okay, yeah, let's create static methods because we would like to reference it like calculator dot. So I can say here int increment and int number, and in this is how I would have created a simple function to increment one value. So I have here calculator and there is one function, and I shared earlier that this function is a normal function, but yes, something equivalent if I have to do, I can also do something like this. Okay, let's say integer, and then here let's say we use some function called, okay, let's say I call add1, right? So here I could say number, add1 is number, use the lambda expression number plus 1. So both the two things are equivalent, right? So when I run it, if I have to increment some value, I can use int number, or let's just directly use it. So I can say calculator dot increment and then use some argument here, because this is our simple function, so I get 5. But if I have to use the same functional interface, I'll use it like this. Okay, here add1, so we called it add1 instead of increment because I can't use the same name, but if I have to use, I would have to comment this. But yeah, I hope you understand this. But yes, here since this is an object, I can't directly put argument here directly 4, I can't pass it. This is invalid syntax because this is a function, this is a function object. So what I will use here is apply function, yeah, and then I run, correct? So this is the concept of how would you convert a function to an object, right? And then I can use composition, functional composition on that as well, right? So this is about functional interface and functional composition. Let's take one more example, which will be, as I said, function interface can work on streams as well. So let's try to work on streams. So let's create a list of integer, and then I say this list is called int list, and then we say we declare it, and we say this is we can declare this list and add some values. Three, yeah. So this is our list. Now list we need to convert to a stream, because if we want to work on work with functions, then we have to do stream. We need to convert it to stream. And then yeah, so if we want to do some operations on this, I can use a map function also, and I can again define some increment operation here, right, like this. And then yeah, so this is my new list. I will get a new list, and then let's print it. Okay, yeah, so instead of like this, I use this syntax, which is more concise. And when I will print this, I get all the array elements incremented by 1. Correct? So the other way I can use is I can pass this function also as an argument here. So I can say calculator dot add 1. Let's see what happens. Yeah, it works. So this is how I can pass a function as an argument to another function. So this is benefit of using this type of function object instead of this classic functions. So if it would not have been static, so I would have to create an object and then I would have to pass this. I could have used like this also, right? So let me try that as well. So let's say this is not static. We make it normal function. We can just ignore this part for the time being. So we have a calculator class where we have one method which is add, and then we have to use it here. So the way we can use it here is I can define a calculator object, right? Say cal c and equal to new calculator, okay, and then I can pass here let's say call it C, and then I will see I want to use add 1, right? So if I run this, so it says invalid method returns, cannot find symbol add 1. Okay, calculator have here add 1. So yes, so did any typo here? So C method reference cannot find and method add 1. Okay, should I use public here to make it accessible? Because yes, I'm calling it directly from here. C is an object, and or what if I call it directly because I cannot call it and it has to be static if I have to call it like this. Okay, yes, I got it. This is method reference, so I can use it with classic functions like increment, right? So yes, I if I would have this method, let's say here increment, okay, and then let's call it static, and then here I have say return. I would say the way I defined it earlier, if I would have used it like that, I pass some here, some number here, integer, and then I say number plus 1, right? Now if you have this method, then I could have used calculator and then increment. Calculator and then I say increment, and this is public. Yes, so should work because I haven't compiled it. Return type return type I need to put. Yes, I have to compile this part, so I'm just clicking on this cell. This is now compiled, and now here I will run this. You see, now it worked, because yes, this is, I can pass this double colon is kind of dot operator, but here you have to reference a method, right? But if I have to call the other component here, which is add one, since this is already defined as a functional interface, I could have used it like add one. So yeah, so both the possibilities are there, because since this is a functional interface, I can use it as a property, but increment is a function here, so I can't use it as a property. But there is a new syntax which is available, which is double colon in Java, which is kind of a pointer to the method. So this is indirectly a pointer concept which has come in Java. So this is very useful, because if you use such syntax, you can simplify very complicated code and make it very maintainable and readable code. Right. So I'll give an example. Let's assume you have a problem where you are given an array and you have to find, this is a simple problem, you have to find difference between the maximum even number and minimum odd number, right? If you have some problem like this, you would need a loop, you would need to track maximum values and minimum values, and then you have to use some logic to determine whether a number is even or odd, and then finally you have to take care of maximum and minimum values subtracted. So this becomes a very complicated code. You would write around 10-12 lines of code, but using streams you can solve these kinds of problem very easily, right? Because how I will solve it in streams, I hope you can try out solving with declarative approach, the classic way how you would solve it, but let me show you how to solve it using streams. Okay, so this is your problem, and what we say do is we define max even, and let's first say we have an array. So we got an array, okay, let's say it's called array, and it has some input, let's say 1 3 5, okay, let's put some number, even numbers as well, and say, yeah, these are the values of arrays. So what I need to do is I need to find the maximum of this. Now I will introduce few more concepts here in this program, but yeah, first thing what you need to do is you need to convert this into a stream. So this could be converted to a stream like this, and there is an object called int stream. So let's call it S. So this is our stream, and then we need to find out, say, list of all odd numbers. Okay, so we can say S, we can filter X such that X divided by 2 equal to 0. So this should give us all the even numbers. So we can just check this by just using what we did. let me know. Feel free to interrupt in case you are getting any doubts and you want clarification. This is our first step, right? So you see I got all the even numbers here, right? Now I have to get some, I want to get the maximum value out of this. So I'll use a max function which is available here, right? Now, in this case, there is also another concept of a class called optional int. Yeah. Let's say this is, we have this, we call it max even, right? So max even when I call, and if I have to print this value, I need to say if present, right? So max even print if present. Let's try running this. Okay, max even is an optional int. If present, okay, so it is, let me recall, is, I will see that, okay, if present, yeah, okay, is present, this is check whether we've got the maximum even number, right? So let's say is present, this was the method, so it says true, yeah, because if our array would have been empty, for example like this, then that's why we use optional int here, because this value may not come. In this case there is null which will be returned here, so that is the reason why we can't use integer here. We use another type object which is called optional int, right? So this is the concept. But yes, if I get this, then I can check if it's present, and if it's present, then I can also try to print this, right? So I will just use tab and get as int, right? So I could use like this, a condition is present, and if it's present, then I can print this, or I can read it in an integer value, which is let's say a. Okay, same thing I can do for the odd part, right? I have already this array, so I don't need to declare this. I already have a stream, so I can say that stream s, and then I can say filter, but this time, right, instead of filtering with even numbers, I can use filtering with odd numbers. So here I'll get odd numbers, and I need min. Right. So I would need here, sorry, I got something overlapped, copy paste. So here min odd, right? So this will give me min odd value. Okay, so one line is this, other line is similarly to print here min odd, get as int, and here I can read the value in B, right? And then finally print A minus B, right? Correct. Or better, I use here system.out.println, right? Okay, so max here I would use min odd, and then min odd present, yeah, min odd, and then I run it. Correct. Int a variable declaration not allowed here. Yeah, so we can do here B, right? And here A is, yeah, Okay. See here, this stream it's saying is already being open. Stream is like water flowing. You can take an example like this is kind of your water filter. So it's going through. So once I've filtered it here, I'm trying to reuse it. What will happen is this stream got closed. So now what I need to do is I need to take a copy of this stream. Right, so because I'm getting an exception when I'm trying to do it for the second time, I'm getting that stream has already been operated upon and it cannot be reused because it is closed. So the solution is I create another stream and from S1 and then filter on this. This is a copy of a stream S, right? Okay, now let's see. Yeah, so I got the value 7 because the maximum even value is 8 and minimum odd value is 1. So 8 minus 1, 7, which is the right output. So see, this is how you would write this code, right? Because if assume you have given this condition that you will not have null array, then you don't need this part. Yeah, you can just say return. I can just return this part max int and then so yeah, this if it would not have been required, I could have done this simply, right, like this. So it's hardly 2-3 lines of code, no for loop, no conditions, if check. It's all just by using functions. So this is how you do declarative programming, because you are not defining the logic, you are just calling the function. You just say, it's like SQL. You say that what you want to do. I want to filter this stream with values which are odd, and then I want to find the minimum of whatever is filtered. So this is what I will get, which is 1. In this case, I take this stream again. I want to filter this with even values, and out of this I want to find the maximum. So this is how you will use this to solve any coding problem, algorithm problem. This is very simple, because otherwise what you would have to do is you have to iterate over the array. You need to use a for loop, and then you would need an if condition to check whether the number is even, and then you need to use a variable. So you see the complexity is so much reduced by writing this kind of code using functional interfaces. Right? So there are more things which you can explore on your own. For example, there is something called bifunction. So this is bifunction. Bifunction could be, let me use this within the calculator class, because this will also help you understand it better. This function add1 takes only one argument. But if you use a bifunction takes 3 arguments. Sorry, it has 3 arguments, yeah. One return type and then the 2 input types. So I can define something called sum, and then I have to use a, b, and which is equal to a plus b, right? See, this is how I will do a bifunction. And if I have to call this, I can use sum. I can use 1 or 2 like this here, and if I okay, this is by function, so I would need to say, I can't do directly like this because this is an object, so I should say apply, right? Because this is a by function. Let me try this now. I am running it. Okay. So variable sum, find symbol, cannot find variable sum, right? So we need to put this as public and run it. Sum is here and it's a by function. So calculator class has a static property sum, and which is of type by function. Yeah, I have to compile it. This part I haven't compiled. Now I will run it and it will give 3, right? So whatever values you do use. So this is how you create a function which is for sum here. And then I can apply this into a stream of numbers also, right? So this stream of numbers could come from a static array in this case, but it can also come from a stream of input stream as well. So assume you have a question for system design where you have to define you have to design a log aggregator, right? There are various servers and servers are sending log messages. So what you can do, you can take a stream of input from these servers and process it using some operations here which is using functional interfaces and using declarative programming instead of imperative programming. So this way you will be able to solve some high level design questions also, because these streams are useful in input output streams as well. So this concept is also applied in how would you process a stream of strings or a stream of inputs, like you are monitoring some performance data, then you can process it using streams. So having the basic understanding of a stream are useful in high level design and low level design questions also, because you can create a stream object and then process it and then store the output somewhere into the database also, because input streams can come from some input source and then you can output these streams to some source which could be database source as well. So as I have given you the previous example, employee class, so this employee stream, rather than coming from the static list, I could have a database query which could get me this stream, and then I can filter out, perform various operations on these streams using these stream functions. So this is how it is useful for designing any business application as well, and which involves input files and databases. So these APIs are very useful in business application, and these streams also allow you, there is a concept called parallel stream. So as I have created a stream, I could also create parallel stream. So here I have I have used the int stream. Let me see if I have used somewhere a stream. This is a stream, right? So let's see if here I can use like parallel stream, and I say employee parallel stream. Let's call this object like this. Let me run this. Okay, parallel stream. We'll use this. I can check this by autocomplete, but yeah, let's try this. Simple. Parallel stream could not be found. Just a minute, let me check the package for parallel stream. So parallel stream are useful in multi-threading programming. So let me check the package and how to use it quickly so that I can demonstrate. So the parallel stream will use the multiple processors in your machine and will parallelize these operations for more efficient performance. So this way you can improve the performance and utilize multi-processors in your systems as well. Okay, I'm getting one example about parallel stream, which will use, we can use parallel streams with objects also, but let me demonstrate an example here. So here I have a logic which is, I have an array 1, 2, 3, 4. Now I'm converting this to a parallel stream and printing the number. So when I run this run is running into different threads. You can see here that this is being run by using multiple threads. So there one is printed. The sequence got little bit changed because what I'm doing is I'm printing the number and also printing the thread which is printing this number. So you see there were 4 CPUs utilized. I see 3. So these are the names of the threads which were printing. So I see 4 threads which were printing the name of printing the numbers, right? So first 2 got printed because that somehow the second thread returned first, and then 3 got printed, then 1 got printed, and then 4 got printed. So this is about the parallelizing. So this was all about functional programming, functional interface. Any queries? Finally, there's a lot more things to cover, but yes, with the time, maybe in next few classes we'll cover, because there are concept of predicate. Whatever value, whatever lambda expression we see here, this is a predicate. We can also define this as an object and pass that object inside this. So it leads to very customizable code also, because now the advantage of passing a function is here instead of add 3, someday I can pass add 6 also, right, or add 4 also. So this way I can use the same code but then achieve different outcomes. So my logic is very configurable, and with very minimal changes I can customize my code. So that is other things to learn. And then these conditions could also be changed. So predicate could be used and or. We can have multiple conditions also within filtering. Then there are supplier functions and optionals we saw. Optional int type we saw that it's not necessary that a stream may give you a result. The result may not be there. For example, in case you don't have any even number or odd number in the list, then you will not have the max even or max odd number. So that's why we used optional int there. And then this could be utilized in creating code which could be like callback. So we covered everything. We covered method reference, we covered lambdas. The final remark is this is called functional programming, and there are some best practices also on functional programming. Like we should not use any variable which is outside this. So it is stateless. The streams are immutable, right? You can't modify the arrays within these streams, and we don't use anything which is outside this stream. So we do not depend on external factors, so that's make it stateless, and this also improves performance, and it also takes care of maintainability. And then we use composition and higher order functions. So what it means is you can combine 2 functions and create another function, as we saw that we can compose new function. Here we did composition. So what we could have also done is we could have captured this value into another function object. So and then created an application apply on this. So I could have say multiply and say multiply and add new function I could define, and then call this with apply. So this way I can compose new functions, and this will become a higher order function, because if a function is returning another function, that is also possible. You can return a function, or you can take in a function as argument another function. This is what we saw. So these are all called higher order functions. And if you use more higher order functions, that is more advisable, because then your code becomes more maintainable and easy to understand. And definitely the number of lines of code also reduces. So this is all about functional programming. Okay, see you then. If no further queries, then we can close this call. Okay, thank you, Kishore.
Thank you.
Can you hear me, Tarun?
Yes, Shrikant, now I am able to hear you.
Sorry, I was trying to make a comment. The style of programming here is similar to that of Python, right? In Python, there are on large data frames when you're processing that. You
Yes.
actually write a function then put dot apply. I think
Correct. Yes.
Java is trying to now support, because I think that was the downside of Java when compared to Python. Now it's trying to probably give that facility as well, and this is beautiful actually, because as you said, one could just read the code and understand what it is doing.
Yes, absolutely, yes.
Yes.
So yeah, these functional. So now Java is not only just object oriented; it is multi-paradigm programming language,
Yeah.
because it can support functional programming, it can support object oriented programming as well. And this is a modern trend. Now more people are writing code this way to get their code more maintainable, and then you get definitely many other benefits also, which we discussed.
Yeah.
Right, very rightly said. And this is not only available in only Python, it's also available in JavaScript also. You can do this kind of programming in JavaScript. And Scala uses intensively the functional programming approach.
Okay.
And if you use a tool like Apache Spark, then Scala is used, and you use a lot of stream programming. Yes, and definitely Python also works well with various clusters to perform stream
Yeah.
options. So everywhere it's used. So it's probably maybe few programming languages started it, but now it's available in most of the programming language.
Thank you, Tarun. Thanks a lot. This is interesting.
Perfect. Great.
Thank you.
See you then.